Hey.
Hey, Zach.
Will you talk for me for a second, Eric? So I can make sure
Yeah,
the
you got
speaker's
it.
out of
How's
this.
this?
Got it. Oh,
All good.
yeah, that's fine. We're good.
Plenty of that. Outstanding. How's font size on the screen share? Am I even still sharing? I hit my
1 second.
I had zoomed back out this morning and I don't remember what Zoom I had it on that we decided was good. So if y'all can see that font okay, give me a thumbs up or let me know, or if I need to zoom in on my editor, I can.
And
Jake and Josie say we're good. I just saw some message. Dancy, I guess, needs the Zoom password. Zach, I don't know what that really means at GetWit.
click the green shield at the top left with the check mark next to the recording thing. Oh wait, that's on my screen. But yeah, you can get the information from that little meeting information thing.
Oh, he just needs the pass key. Okay,
It's
I see.
449652. I'll put that in Slack.
I see a Dancy now, so I think he's listening and you're typing. So I think we'll be set. Thank you. I thought he meant some password to GetWit to get into the Zoom account or something. I didn't.
I just need the Zoom link or the Zoom password.
The pass key for the meeting.
Right.
Yeah, Zach just dropped it in
Can't hear you anymore, Eric.
the cohort. Did you say you can't hear me anymore, Zach? Weird. Zoom thinks it can hear me.
Eric, I think I lost your audio.
Can anybody else hear me on the Zoom meeting? Is it just the OKC room?
Oh, that's me.
I can hear you.
I can hear you. Yep.
Yeah, it's you, Zach. Somebody in OKC tell Zach it's Zach.
It's me. Can you guys hear me?
Yeah, I can hear you. Not that me answer.
All right, there we go. We're back.
All right, cool.
Okay.
All right.
Think
Oh,
we're-
and I see a Tulsa room in the curve. Fancy. Oh, and it's
Sweet.
zooming in dramatically on Fancy. Nice. Well, good morning, everybody. I think now that we have both the big rooms in, I'll assume we're good to actually get rolling here. I know a few people were joining remotely and a few were out sick. So sorry for those of you that are sick, and glad that I'm able to be with you all this morning. I decided to join from home this morning after the way the AV and big room went with me and stuff yesterday, and I had stuff going on. So I hope that's okay, Tulsa people. I'll be with you for the next build day. You can get my undivided attention in the room. We are nearing the end, friends. This is class 6 of 8. So we got 2 left in the intro. Hopefully that doesn't induce any panic in you. I want to point out that means that you have a whole nother module of JavaScript coming. So, plenty of time to keep diving into this stuff. So Anybody have anything super burning or blocking for them they want to throw in the chat or anything before I dive into some objects? We're going to talk about objects primarily today.
I just have a question about the series. So I found the message from Emily in the chat, and it's going to be recorded for us, or are we like, is it going to be part of the recorded session for this class, or we're just going to jump right in, or is it going to be something separate that we have to log into?
That's a great question. Zach, do you know how that's working? Because it's Tabby and OKC given the talk today, right? OKC folks, can you still hear me in that room? Or did we break Zach's audio again? Okay,
You can.
thumbs up in there. Okay, yeah, hey, Allie was asking about the speaker today. Tabby's talking after class, right? And is that a separate recording or is that
Zoom.
just roll right in this? We'll just keep this one going. Okay. So there you go, Allie. It'll just be baked onto the end of class.
Thank
So we'll
you.
do 2 hours of class and then at noon the speaker will start and Tabby will talk and we'll just keep the recording going.
Thank you.
Awesome. Anything else, gang? Chat open here so I can actually get that on a screen where I can see everybody else also. Just wanted to shout out those of you who have been posting questions since last class in Slack or DMing me. I've had good chats after class with Jason and some others, and then also good one-on-one exchanges with some of you since then. So kudos for you for making the effort to reach out. And I hope that you're all feeling a little bit more unblocked after the conversation about approaches last class. I do want to point out something that came up out of a couple of those one-on-ones. Talking about your code and asking questions about it is its own skill. So some of you were asking about prepping for technical interviews and all that kind of stuff. I wouldn't worry about that till you're getting closer to interviewing too much. But one of the things that is critical to practice, both for that and in general, if you're interested in doing this professionally, is to be able to talk about your code. And that just literally takes practice because you're learning the language, right? So again, we used the language analogy last class. Like, imagine you're learning a foreign language and then you're trying to explain that foreign language to somebody else. Like, you learning to talk about the language instead of talk in the language is its own set of skills, and it just requires some practice. Know that whenever you have to type in front of somebody else on a live screen and talk about your code, you will forget how to do one of those three things. You either won't be able to code anymore, won't be able to talk, or won't be able to type. And so it's just what happens. It's nerves, it's things like that. And so getting used to that feeling coming up and being like, oh, I just forgot how to type. Haha, I can remember how to type. This isn't a panic moment. Requires exposure and practice. So don't wait for that for the last minute. Right now, you have a great cohort for the next several weeks and months to talk about your code with. And the more you talk about it and try to talk about it, even if it's hard to figure out how to talk about it, that's how you're going to get better at talking about your code. And that's how you're going to get better at asking more specific questions. And I know with some of you we exchanged, not to put Dancy on the spot, but he has a great help thread and we had a good back and forth about a shopping cart. Like, those are great bits of practice, being able to share specifically what you've tried, what you haven't tried, what you think is the problem, and how to talk about those things in ways that help other people help you is really a learned skill. So I just encourage you all to leverage this sort of quote free time you have while you have this cohort in a safe space, right? You're all learning together. So talk about what you're talk about what um, is a developer or anything. Well, anything that would be causing.
Are you guys still there, Tulsa?
Yes.
Yeah, we're here.
I forgot I'm not in I get it right now.
All right. Now y'all's video is breaking up for me, so I'm assuming I'm still breaking up for you.
We can hear you.
Okay.
we-
Maybe I'll try if the audio is not cutting out. Let me see if I just kill my camera to reduce bandwidth, if that helps.
I'll do the same here.
Okay, is my audio cleaner, everybody? Is that better without cameras, etc.? I see Jason nodding, I see thumbs up in Tulsa. Cool. Okay. All right, so I'm just going to circle back a little bit on what I was saying, which is, ironically, practice talking about your code. You all have a safe group to do that in right now, where you're all learning together, and you all are not only learning how to code, but you're also learning how to talk about your code. So you should be a good support group to practice that. And that includes like being willing to accept and give constructive feedback on, hey, I don't really understand the question you're asking. Can you ask it in a different way? You know, those kinds of things. It is a real world job skill as a developer to be able to ask for incisive help. And what I mean by incisive there is like, usually if you're asking for help, you're often either going to a colleague at your level or up the chain to, you know, a technical lead on your project or a senior developer or something like that. Their time is even more expensive than yours is. So asking pointed questions that help them help you quickly and efficiently is a sign of professional respect and also good for the company in general. So you want to ask questions early and often, but also be able to document in your questions, like, here is what I believe my current problem I'm trying to solve in. Here is what I have tried. Here is what isn't working. These are error messages I'm getting. You know, think about like how you talk about what you've tried. Questions like, I don't know how to do this, without any more specifics, are not very easy for people to help you with. So it is also a good learning experience just to figure out how you narrow down what your question really is. And for me, I know I'm going to sound like a broken record at this point, but that comes back to this practice of reading code. If you read through the code you're writing and that isn't working the way you want, that you have a question about, and try to explain to yourself like you're 5, like, this is what this step is doing, and this is what this step is doing. These are working. Here is the step that is not working, right? And then I can talk about that simply. Often you will find there's this experience of rubber ducking. I don't know if that's been talked about yet in your earlier modules, but it is not an unsurprising thing for people to actually have a literal rubber duck on their desk. For me, I'm a Avatar Last Airbender fan, so it's an Appa and Uncle Iroh Funko Pop dolls. Those are my rubber ducks. If my camera was still on, I'd show you to them. But the idea is, it is when you don't have somebody else available to talk through your code with, just talking it out helps. Because by trying to explain in simple human English, or whatever your first language is, what is happening in the code and where it's not working, you force your brain to kind of simplify the problem, focus on the perspective. And so I think part of the key thing there to realize is this happens to me all the time. I will ask for help with something I'm stuck on, and in explaining the problem to the person who has jumped on to help me, I go, oh, wait, never mind. I know what I'm doing wrong. It's right here. So the act of actually talking through the problem and trying to ask the question often points out the obvious thing you may have missed before. And so that's where the idea of rubber ducking comes in, is that even talking it through with an inanimate stuffed animal or rubber duck or whatever on your desk is a useful practice in talking about code and being able to reason through what you're reading in your JavaScript to say, okay, I see at least where the problem is, even if I don't know what the problem is, right? So practice those skills, and cannot advocate enough that you make use of that while you're in the cohort here. Cool. All right. So with that said, let's dive into JavaScript objects. We now hopefully, talking about the way we've been flowing through this class and trying to get you all unstuck, this should not be our first exposure to objects at this point. So we are not teaching this module in a way in which you're getting introduced to concepts one at a time and doing a deep dive in it, right? Like you've all written at least one object by now, I hope, because definitely did plenty of them in the Dragon Slayer exercise, and you've used them in other places, right? So just as a quick overview of where we're headed before we dive too deep into objects. Today we're going to talk about objects and all kinds of permutations of objects. Then on Wednesday, we're going to get into iterators. So how, when we have to do stuff over and over again, do we do that efficiently instead of just coding all the steps separately, basically? And that's it for this module of new material, okay? So as I mentioned last class, try to get through that palindrome checker certification before you start the next module. Like if you can finish that level of the free code camp stuff, I think that'll be good review, practice, exposure to what we wanted you to get out of this class. And our last day will be all next additions to your coffee shop build day. So I'll just be there helping in Tulsa. We'll have the mentors in OKC. You all can hit me up with questions in the Slack as we go, but that's kind of how we'll wrap it up a week from today. Okay. So that's the big overview. Let's get into today. So why do we use objects? Objects are the idea of being able to group multiple values together, and those values could also be behaviors, right? So we call them methods when we're talking about functions that belong to an object. So we have this idea of, hey, there's some properties, maybe it's name and age, for instance, and we have some behaviors like walk and talk. I'm starting to describe a person, aren't I? So having a person object might make sense, where I can think about this person as an object when I pass them around in my code, and then I can access things about them, their properties, like their name or their age. I can ask them to do behaviors like walk, run, speak, etc. If I have methods. And so those things all being tied together should start to say to my brain, this is a good use for an object. The whole idea of object-oriented programming, which is a deeper, bigger topic you'll get into in the next module, is born out of this, but the general programming idea of an object is basically to model the real world domain. So what we mean by that is, like, if we're writing an app, let's say, where we sell cars to people, it is going to be a lot easier for me as a human to reason through that app if I have an object type called a car. So cars are cars. Cars always have a make, a model, a color, whatever it is, but they're always going to be a car. And a person that I'm selling that car to is going to be a person. And I might have a sales rep that has some different properties, and that'll be another type of thing. But by being able to group all of those properties and behaviors together that sort of mean something in the real world, it makes it much easier for me to start to think about my code as moving real world objects around and manipulating them, as opposed to just a bunch of discrete separate variables like person 1 first name, person 2 first name. You can imagine that's going to start to get real annoying real quick when you have 1,000 people in your app, right? So having them all just be able to be a person and then being able to read stuff about them is useful. So in our shopping cart example here, like what we're thinking about there for starters is your items, right? So you have these items you created. Those items have a name. They might have a photo. They have a price. They might have a longer description than just the name. You know, these are sort of things that make up, quote, an item in our shop. So good use for an object. Don't have to do it with an object, but it starts to make a whole lot of sense if I can just think of a menu item as a thing that has some properties I can rely on it having, and some behaviors I can rely on it having. Okay. Any data type you've used for a variable so far can go inside of an object. Okay. So an object can contain other objects. An object can contain arrays. It can contain strings. It can contain numbers. It can contain all of these things. Okay. So you can really think about an object as a container that is meant to model the real world counterpart often. There's some other uses for them, but that's the primary reason for using an object. Okay. And at its simplest level, an object is just a set of key value pairs. Okay. So when we look at an object, for instance, I'm gonna pop over here real quick, looking at this shopping cart object right here, we can see that inside our curly braces that define this object literal here, we have some properties and we have a behavior. Okay. It's a method, because we know that because it's a function. Functions do stuff. So if there's a function in there, it's got to be a behavior, right? So key value pairs. So here are keys in this object are name, price, description, quantity, right? And say hello. Those are the keys. Their values are the string dog toy. The value for the key price is the number $4.99. The value for the key description is your dogs will love it. That's a string, right? The key quantity has the value number 2. The key say hello has the value of this function, right? This is the definition of a function. So we're not calling the function here or running it, we're defining it. So we're saying, okay, cool. This shopping cart object, if I call say hello on it, it will run this code. Okay, but you can see even with the functions, it's still the basic idea of a key, colon, and a value, right? So this is how we structure an object. They are just a combination of key value pairs. We can store them in a variable, and then we can act on them from the variable. So you can see we're storing the actual object here is curly brace to curly brace, right? And we are storing it in a const called shopping cart object. Notice it's a const, but I might want to change the price or the quantity, in this case, since we're tracking quantity directly on the object, right? I can do that because I'm not actually changing the object itself, I'm changing its properties. So when we define an object like this, we will typically use a const because you're saying this container is always this container. That's the part that's constant. Everything inside of it can be modified. We can add properties to it. We can remove properties from it. We can change the values of those properties, but the container is still that object. Okay, that's why it's a const. Does that make sense? Just saying it's that object over there. The same is true of arrays. If you remember when we did the dive into arrays, we said the same thing. You'll typically define an array as a const, even though you can push stuff into it and pop stuff out of it, which changes the array. Your array container itself, those original square brackets you drew are still the same container. So the container is constant. An object works the same way. Okay. So it's very much like an array in that sense. If you just think about like those square brackets of an array, create this container, you can put stuff in. Our curly brackets create a container, we can also put stuff in, and the container is constant. The difference here between an array and an object at the most basic level is how we access what's inside that container, right? So in an array, how do we access stuff in the array? How do we get to an item that's in an array? Anybody? I lost my chat. Somebody throw me something in the chat. You all know how to get something out of an array. Somebody does. Anybody? I don't know if I don't have audio from some of you. That might be
Use
it.
the index.
It's the index. That's it. Exactly. Right. So, and the index just represents the position, right? So if I have, if I have this array, const sum array, and I have foo, bar, Baz. If I want foo, I'm just going to access it at sum array 0, right? That's my first index. So we're getting things out of the array by their position. So the order of an array matters because it's the only way we can get anything into or out of it, right? We know when we pop, we take the last thing. When we push, we add it to the end. When we shift, we take the first thing. When we unshift, we push it in the front. So everything about an array is order dependent. It is all about indexes. In an object, order is irrelevant. Okay. In fact, it is not stable in JavaScript. So you cannot assume, like if I asked, and we're not going to get into the details of it, but I can ask, there is an object.keys method, which will list out all the keys of an object. Okay. You are not guaranteed to get those keys in any specific order. So that's important to know. Even though I've listed these things this way, as far as JavaScript is concerned, I could rearrange this and put price first and name second, and it doesn't matter because I can't access it by position. I have to access by what? How do I get a value out of an object?
Dot notation.
So yeah, we either use dot notation or bracket notation, and we'll look at why you do use one or over the other, but we're accessing by the key, right? So when we want something out of an array, we say, give me the thing at this position. When we want something out of an object, we say, give me the value that this key holds. Okay, so you can literally think of it as like a bunch of safety deposit boxes. Like every line in your object is a little safety deposit box. And when you hand the object the key, it's going to go unlock that box and hand you what's in there. Right? It's key value pair. So if I want the name from this shopping cart, I can get it object, I can get it two ways. So I could say const name equals shopping cart object dot name. That would work. I can also do, going to yell at me for declaring the same name also. Do that. Shopping cart object name. Those are functionally equivalent. They will both hand me back the same thing. Okay. So why do we need two ways to do that? Well, notice that these are properties are strings. All of these keys are strings. Okay. If I try to use a not string and I'm like 2 is foo, JavaScript will be very unhappy about this. It's not apparent right now, but when I try to actually run this or do anything with it, this is either going to get coerced to a string or it's going to yell at me depending on strict mode. String keys in a standard JavaScript object have to be strings. Okay. But you notice we aren't putting these in quotes. Okay. That's a shorthand. That's all it is. They are still strings. I could absolutely do this. And that would be valid also. Same result. Okay. The shorthand here is that I do not have to quote my string keys in an object if they conform to what is called an identifier in JavaScript, which basically means you don't have any weird characters in there. So the rules for an identifier are that it can only contain numbers, letters, and the $sign, and it cannot start with a number. So we check all those rules here. We don't have spaces in these, we don't have weird characters in these, and they don't start with numbers, so we don't have to quote them. That's fine. But if I wanted a key that was first name, I can't do this. You can see it's already squiggling me, but I can do this. That's fine. Okay. So that's the difference there. Otherwise, they're still just string keys. Now, if I do this, then down here, I can't get first name with dot notation anymore because I can't type this. JavaScript doesn't know what that is, right? But I can do this. And that'll work just fine. Okay. So that's one of the two reasons you basically need, common reasons you need bracket notation. If for some reason your key needs to be something that it doesn't match identifier rules, and so you have to quote it, then you're going to need bracket notation to access it. That's all there is to that. But I could also do, wait for it, property, sorry, I just started writing PHP, y'all, forget that, work habits. Property I want equals first name. Oops. Sorry, been weirdness there. I can do that too. So this is the other good reason for bracket notation is sometimes the property you want to access in the object is tied to some dynamically changing variable. I want to go get whatever property that variable is set to right now. So bracket notation is also what you'd use for that. I can't do this because there is no property inside shopping cart object called property I want. But when I put that in bracket notation, then it's going to assume, since this isn't quoted, that it's a variable because it needs to be a string because object keys have to be strings. So it's going to assume it's a variable that contains a string, and it's going to go get the string inside that variable. Does that make sense? So it's kind of a powerful way you can programmatically access keys in an object. So all that to say, you can use dot notation for any of those non-quoted keys. So quantity here works just fine. Okay. You have to use bracket notation if it is a quoted key, or you want to use a variable to tell it which property to access. Does that make sense? All right. I mentioned briefly, you can update the object from the variable or add new properties to it. So in here, I can also say, let's decide, I can do shopping cart object dot quantity equals 3. And now this value just got updated to 3. So if I access shopping cart dot quantity again down here, it's going to have the new value. I just modified the value at that key with dot notation. But you can also dynamically add a whole new property. So I could do that. And now if I I'm just going to show you what I'm doing here in the browser. So this is going to log out an array of all the keys in this object. Okay, and what I'm going to do is do that before and after we do this. Okay, and then I'm going to pop over to my browser tab here, which exists here. I shared screen, full screen, right? So you all can see the browser tab right now. Yes. Zoom in on the console here. Refresh this guy. Okay, so you can see this is the first log of the keys. First name, I'm going to spill it out. First name, price, description, quantity, and say hello. Here's after I made those two changes. So I still have the quantity key because I only changed its value. I didn't do anything else to it. But you can see I now have a key for new property. So my object just got one key longer. It has a new entry in it. Jake, I just saw your question. Dot notation and bracket notation applies to other objects such as functions. So not necessarily to functions really, because your function, so this is one of those places where on day one, I mentioned that like everything in JavaScript is an object at some point. So if that's what you mean by quote other objects, then absolutely that is correct. If you are accessing, for instance, when you have a string and you want to call string dot split on that string, that is accessing a method on the string object with dot notation. That's all you're doing. It's exactly the same as what we just demoed. Right. So if I have const sum string equals foobar, and then I do sum string dot split, which now split that up in all my individual letters because I passed an empty character. What happened here is when I tried to do this, if you remember back to the first week, I mentioned this idea of ephemeral objects in JavaScript. So JavaScript said, okay, this is a string literal. This has no properties and no methods. But I tried to do something to it by calling a method on it. The way JavaScript works is it said, okay, cool, I'm going to wrap this string literal in a string object with a capital S instead of string with a lower s, which is just the type. And that string object contains this as the value, but it also has all these cool things I can do with it, like dot split or some string dot length. I can access properties on it. It's 6 characters long. That's because every time I do that, JavaScript takes my string literal that is just the text foobar, wraps it in this magical string object, lets me do stuff to it, and then throws that string object away again when I'm done. You don't need to think too much about that, but I just want you to understand that these ephemeral objects happen with numbers and strings and all those things to answer Jake's question, which is why we can do dot something on a string or dot something on an array or dot something on any of our other data types, numbers, etc. And that the reason for that is because JavaScript is wrapping them in objects that have those methods and properties. So there's nothing magical about the dot access or bracket notation we're doing there to get to stuff on these ephemeral objects. The quote magic is just that JavaScript is creating those objects on the fly for us and then throwing them away when it's done with them. You can create one yourself with capital S string. That is the string object. That's what JavaScript is effectively doing. This is what's called a constructor function, and we're going to talk about that in a second here. So this makes a string object with that as its value. You've seen this already when we did things like number2, which gives me the actual number type 2. It created an ephemeral number object, passed it the string, and tried to turn it into a number. Okay. So does that answer your question, Jake? Sound good?
Yes, thank you.
Awesome, you bet. All right. More fun with objects. So when you've stored the object in the variable, like we did here, you've seen I can change the values at keys. I can add new properties. I can also delete one. So if I do delete shopping cart object dot description. I may have to set it to undefined first because I think this is going to default to strict mode now, but I'm curious. So let's just refresh and see what happens. And now you notice I have 5 before and 5 after in my keys. Because here, even though I added new property, we deleted the property from that object description. So at this point, here, shopping cart description is shopping cart item description is whatever that text is. But after I delete it, shopping cart description would be undefined. I've deleted the property from the object altogether. That actually removed it from its keys. So I could also just do, if we want to just say like, I don't want to remove the property, but I want to say this item doesn't have a description, I could do that. Remember, null is our type for intentionally saying there's nothing here, not that it's undefined and we don't know what it is. I know what this is. There is no description for this item. Setting that property to null would also make sense. But you can see if I do it that way, now when we look at this, my second log has 6 properties. Description is still in there, but if I logged out shopping cart object dot description, it's null, right? Because we nulled it out. Okay. So that's how we kind of modify the values that are being held underneath the keys of an object or insert a new key. There are other flavors of this if you're curious of this method. So you can also do object.values, which will only list all the values. Let me label these for you. Values. And now you'll see, so that values method just gave me all the values with none of their keys. And this is an array of their values. Right? It returns an array. So that looks a lot like keys. And then there's a third flavor of that you can do, which is entries. Here, actually, let's do this. All right, so now when we see that, okay, so when I get the values of that object, right, I just have the string dog toy, the price $4.99. I don't know what any of these are. I only have them by position. And that order is not reliable. Remember, I told you when you get stuff out of an object, the order you get the keys in is not dependable. Don't ever assume they're going to come out in the same order. So there's my values. If we look at the keys method, we get just the keys, right? First name, price, description, quantity, say hello. Notice these are all quoted strings now because that's really what they are. They've always been strings. It's just that we don't have to quote them to save ourselves some keystrokes if they conform to that identifier rule. It's a shortcut. They're still strings. Okay. And then entries gives me an array of arrays. So here I get the key and the value for each thing in the object in an array. So I have the string and its value, 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 the string and its value. And if I open this one up, you can see its value is a function, right? That was our say hello. So the key is say hello and the entry is a function with all this stuff because a function is also an object in JavaScript because everything gets turned into an object. It's a function object. All right. Cool. That's basically how we put stuff into objects and how we get stuff out of objects. Anybody have any burning questions about that before I move on to how we actually create objects? Because curly braces ain't the only way. I'm gonna give you some new tools today. Watching chats, checking things, think we're okay. All right. So primarily for dealing with objects right now, we have just created object literals, and you'll do this all the time. So that's just curly braces with some stuff in it stored in a variable. We've made an object literal, and it's just like this is a string literal, this is an object literal. I'm literally writing out key value pairs and curly braces and saying this is the object. We're not creating it programmatically, we're just defining it as the value of a variable, writing out the object directly. That's why it's a literal. Okay. So we have a few other ways that we can create that, because you can imagine, again, like let's go back to the like used car sales app example. If I had to manually type out or literally type out the object for every user and their names, their addresses, their passwords, whatever, over and over again, like that is obviously just going to get wildly tedious, right? So there's some other things that we can do with objects that become pretty useful. One of them is constructor functions, okay? So you notice that when we've written functions, like say hello here, the convention in JavaScript is camel case. So lowercase first letter and then an uppercase letter at each word break, right? That's camel case. The JavaScript isn't sensitive about that. You could name a function in all caps if you want, but it is not the convention, so don't do it, okay? Camel case, just like we use for our variables. There is another convention that when we create a constructor function, that we capitalize it, okay? But it's just a function that creates an object. That's all its job is, all right? So let me pull over here. I had an example for this pulled up real quick, so I don't have to type the whole thing out. This is just a W3 schools example, which is going to save me some typing for you. So it's a function just like we've declared every other function, right? And we're going to do that. We'll redo this in a real example in our current code in a second. But notice it's a capital letter in the function name. That's just a convention. It doesn't do anything fancy in the code. It just says, oh, this is a constructor. Okay. It takes some arguments just like any other function. But now we're seeing this word we haven't dealt with yet, and we're not going to get too deep into the weeds of this in this module, but it's the this keyword. Okay. All we're going to say about this for now is know that this refers to an object always, but what object it's referring to can be very different depending on the context. Okay. There is actually linked here. There's a whole little thing here, so we can just look at the quick basic lines. If you are calling an object, a method on an object, so back in our example here, when we call say hello, this inside of here would refer to the shopping cart object. So if I referenced this dot quantity in here, you can see we're doing it with name right here. We're saying hello this dot name. That means the name on this object that holds this method. Okay, so when we're calling an object method, this means the object that owns the method. If you just reference this in the top level scope and you're not inside of an object or anything like that, it's going to refer to that global object, which in the browser is the window object. We haven't really dealt much with the window object, but know that it exists. So global available browser properties exist on the window object. And the window is essentially the object that represents your browser to JavaScript. Okay, so there's that. If you're inside a function, this will also refer to that global object. So if you just use this inside of a function that's declared on its own, it's going to refer to the global this. Unless you're in strict mode, which then this will be undefined inside a function. So depending on whether you're in strict mode or not, this will be global or this will mean nothing inside of a function. I want to clarify that that is different from that object method. Yes, this is a function, but it's a function stored under a key inside an object. So it has a this to refer to because it exists inside of an object. Okay, but if I just wrote, function whatever on the outside and used this inside of it, this would either refer to the global window or whatever environment we're operating in, or it would be undefined because there's no object to be this. Okay. In an event, so we dealt with this a little bit if you were following the helping Dancy with the shopping cart. We were passing events around. So whenever you deal with a click event, like an on-click or any other event, that listener gets handed an event object. That event object has a target on it, which is the element that triggered the event. This, in the context of an event, is the element that triggered the event. So your onClick handler can use this to refer to the button you just clicked, for instance, because that also is an object. In this case, it's an HTML node object. Okay. And then there's all these other methods, call, apply, and bind, which lets you actually directly say, for this block of code, this means this specific object. We can pass it an object that will be this for the purposes of the following bits of code. Just planting a really high level seed there. Don't worry if you only understood about 10% of that. Just plant for now that this refers to an object and it might be undefined. But if you're dealing with a method inside of an object, which is where you're going to deal with it most of the time, this will refer to the object that that method is coming from inside of. Okay, that's going to be your most common usage of that for now. So again, here, say hello is a method that belongs to shopping cart object. So this refers to shopping cart object. So when I say this.name here, I get the name property up here, which is currently going to be broken because I got rid of the name property. Let's go see how that's behaving in the browser, just to give you some fun clues here. Hello, undefined. That's not a very good greeting right here on line 21, right? And we can see if I click my little source map, that line 21 is exactly the line we were just looking at. Come on, debugger, get bigger. Resize arrows being fussy today. Okay, so that error we got in our console here, it wasn't an error because JavaScript again tries to be as permissive as it can get away with. So it just said, cool, hello undefined. And it said hello undefined because in here, what we're saying is hello plus this.name. Well, this refers to the container object, shopping cart object, and shopping cart object has no name property. So this.name is undefined. So if I set this key back to name in my code, so, and now I go back here and we look at our console again. Now it's hello dog toy. Make sense? Cool. All right. So when we want to create a constructor function, let's say we know we're going to create lots of shopping cart items, right? So I don't have to mess with this variable name. I'm going to create a new one that's shopping cart item instead of shopping cart object. And just show you kind of how that would work. So what we could do is function capital, because it's a constructor. And then what is that function going to need to know to construct an object? We're going to need a name. We're going to need a price. We're going to need a description. We're going to need a quantity. Okay. Notice I didn't ask for say hello because I'm not going to pass in a whole function here for now. You could absolutely do that. I don't need to right now. And then in here, all this function is going to do is say this dot name equals name, this dot price equals price, this dot description equals description, this dot quantity equals quantity. Okay, so I don't want you to confuse these two things. This is the key name when I create the object. This name I'm setting it to is just the name of this parameter. So I could set this to some name. And then this would have to do the same thing. If that helps that be more clear. So here I'm just naming parameters, and here I'm setting properties on the object. It is pretty common practice though, unless there's a reason it helps it be more clear to not do that, to just kind of name them the same thing. And then you end up with this code that often looks like this, which is this thing equals this thing. Okay. But I could pick any names I want for these parameters as long as I know what they're supposed to represent and what order they're going to get passed in. But you can see if I named them anything else, it would be kind of hard to know how to use this constructor because I wouldn't know what the first argument was if it wasn't named something that made sense. Okay. So now let's make one. I'm going to say const new item equals new. Okay, here's where constructor functions work. You can use the new keyword with them. New shopping cart item. And then I need to pass it what I want. New name. This one is $9.99 because that's a good price. My shiny new constructed item is my description. And we have 7 of them because that's a good number. And I'm just going to log that item out. Here's my new item. Just kidding, that's my old item. Here's my new item. Refresh. Shopping cart item, it's right here. Okay, so you can see we have my shiny new constructed item, my name. Notice this looks exactly like our other object literal on the inside, except it now knows what kind of object it is. It is a shopping cart item because it was constructed with that constructor function. Okay. So I could then, the power of this is I can just make another one really easily. This one's only 99 cents. Some words for a description, and we have 3 of those. Okay. And now if we go back and look, you can see I got my 2 items, but I'm getting this handy clue that they are shopping cart items because that's the constructor I used to build them. Otherwise, you can see it's still just an object literal with the same keys and values. So what it produced at the end of the day is really no different, except that it now knows it's a shopping cart item because I've used a constructor function to build it. Okay. So when you're creating things over and over again, this can be a useful pattern. Hint, hint, might be useful for shopping cart items that have a constructor function. Okay. So that's another way we can create an object. So we can just do a variable, curly braces, build an object. We can write a constructor function, which we capitalize the name of, and then that lets us say new with the object and the values that need to get injected, and then that constructor function can build it up. But I want to point out one difference between my constructed items and the other one. Which key am I missing?
Say hello.
Yeah, I don't have my say hello function in here, right? Because I didn't include it at all. Now, I'm going to assume that every time I get a shopping cart item, its say hello function should be exactly the same. So I don't want to have to pass that function in over and over again, right? Name, price, description, and quantity might change every time I have a new item, but say hello is going to always be the same. So basically, the way we handle that is down here. I can do this dot say hello equals that, right? And then because this isn't getting passed in, every time I create a shopping cart item, it's going to take the 4 things I pass in and set those, and then it's just going to add this function every time, always. And so now that I've done that, if I go back and refresh here, oh, you're mad at me about something. Where did I unclosed the thing? Oh, it's my comma in here. Okay, so now you can see my shopping cart item has the say hello function at the end of it. So now it works just like the other ones did. Okay, so in a constructor function, you're not limited to only setting properties you pass in. You can also set properties that are the same for every time that object ever gets created, however you would like, right? So for instance, if I wanted to have a, these are all from the same store, I could do that. And then every shopping cart item that always gets created will have the store property set to my store because I'm not passing it in. So it's not changeable at creation. I could change it later. I could then grab this new item and do new item dot store equals something else and change it on that object. But at creation time, this would be a fixed property. This would be a fixed property. These would all be set by what gets passed into the constructor when I say new one of those things. Okay. So that's a constructor function. And this is starting to get us into the idea of a prototype. So we're not going to get into inheritance and object-oriented programming and stuff in this module, but know that all JavaScript objects have a property of prototype. And that prototype is basically another object that says these are the properties and methods that are the same for every instance of one of these objects, as opposed to what we would call instance properties, which would be like on my new item here and another new item. These guys are all instance properties because they can be different from my new item to another new item, right? So on an instance of the object, it has its own unique set of values for those. Those are instance properties or instance methods. Prototype properties or prototype methods would be the same for every shopping cart item I create. So if we have this dot say hello, I could also add to the shopping cart item prototype this function and then not have to set it in the constructor, and it would always happen. I'm planting a seed there. Don't get too deep into the weeds of inheritance. We're not going to carry on there, but know that basically every object inherits from a prototype. And if you think about the word prototype outside of JavaScript and just sort of in regular English land, that's the idea, right? We have like a model for how a real one should work. So the prototype says like, cool, start from the prototype and then change what's different or add what's different for this instance built off of that prototype. That's the idea of a prototype. And the only reason I'm even touching prototypes right now is that another handy way you can create an object is with object.create. Okay. And when we look at object.create, what it lets you do is, I'm just going to pull over the MDN docs for a second here for you. Okay, so here I've defined an object literal called person. Let me zoom this in a little bit. So we just have a regular object literal like we did before. It's got a method called print introduction and a Boolean field called is human. That's it. Okay. But then I want to make a new person object that's me. And I don't want to have to type all this stuff in directly again. So I can say me is object.create and then pass it person. And what create is doing here is it is saying person is the, oh, I didn't know I could change that. It is saying person is the prototype for me. So me is going to inherit an is human false and a print introduction function. It will just start me an object that looks exactly like this person object called me. And its prototype will be person. Then I can go in and change the name. I could change his human and I can call print introduction because print introduction existed because I inherited it from the prototype. Okay. So that's object.create. So if you have these objects like your shopping cart items, or if you remember back to the Dragon Slayer role-playing game, the locations, same idea. Like we were just hard coding those locations in that role-playing game. Every time we added a location, we had to build a whole new object from scratch with the new curly braces and write out all the same keys. That would be a great use case for either a location prototype where we just said const location equals, and here's what's the same about all the default values for every location. And then we could just do const whatever our new location is object.create and pass it the location prototype. And then we can change whatever we need to change about it. That would be one way. The other way would be similar to what we just did with this constructor function. And we could have written a constructor function that was function location. And I don't remember what all location had, but it had, I don't know, a name. And I have to go back and look at that exercise because I don't remember what all was in there. Anybody else remember what the properties on a location were? Let's use this as a good example. I'm going to grab it. Get there quickly. So in that script.js location, so we had a name, we had button text, we had button functions, and then we had the text that got displayed. And just for clarity, I'll call that display text. Now in those functions, they used button text and button functions as keys with spaces in them, so they were quoted. So we can set that up, but we're gonna have to use bracket notation. So to build the exact objects we were building, here, let me grab one of these out of the thing so we have an example of what we're creating. Make it easier for you to look at all this in one context. Now my syntax formatting is getting weird because I'm in a comment, but you get the idea. Okay, so this was an example of what one of our locations looked like, right? So we had, actually, let me do it now. Let me let you get the syntax highlighting. Const sample location equals. Remember I said you can't type when other people are watching and you're talking about it? This is what's happening to me right now. Okay, thanks, Tondalia. I see that. Okay, so you can see this is what we're trying to create, right? Notice that I did not use button text like this here because I can't. It's a function parameter. I can't pass a string. A string is a value, and I can't have spaces in a parameter name or a variable name. So to create this, we do this dot name equals name. We do this. Now I got to reach for bracket notation to use that key. This button text. Okay. So this would be a constructor function we could have written that would have built location objects for us. And then if we wanted a new one, we could do const new location equals new location, call our constructor and say my location button text is also text. So, but it's an array of strings, right? Notice this here, it's an array of strings. So here I would pass in something like button 1, button 2, button 3. Oops. Those also could be variables that referred to strings that were defined somewhere else. And then we need to pass in our button functions. So those need to be functions. I only have so many functions in here. So for now, I'm just going to pass in shopping cart item and location, which is a little weird that I'm passing in constructors, but I'm just trying to get us an example. And those are functions I have on the screen right now. So passing in an array of functions. And then I'm passing in the text. So our display text will be check out this new location. That's going to make me a location, right? Now notice this would have broken in our game because I have 3 buttons, but only 2 button functions. So I wouldn't have anything to assign to that third button, which would be weird. So this is part of the other power of constructors is we can do some validation. So we could say something like if button functions dot length is less than 3. In this case, what I would do is throw an exception. We haven't talked about exceptions at all yet, but you can do a throw new error. You must provide 3 button functions. And this means that when we do this here, this code is just going to break. It's going to throw an error in the console and tell us that we didn't put in enough button functions, maybe. Go store is not defined. Where did I, oh, because I actually, that's why I had this commented out before, because it's referencing stuff that doesn't exist. Okay, you see now I have an error. You must provide 3 button functions, and nothing else happened. None of my other code ran, nothing else logged out, because when you throw an error, it stops everything. And there's a pattern called try catch, where if you know some code you're running might throw an error and you don't want it to break everything, you tell it to try running that code, and then the catch block, you tell it what to do if there's an error. So for instance, I could do this here and say, try to do this. And then catch, and catch will take 1 parameter for whatever you want the error to be called. It's common to call it E or error or something like that. You made a mistake. And then I'll log the error out also. So now, instead of this getting thrown right here, it's gonna throw. But when I try to make this new location and I don't pass in enough of these, so this check here fails, when it throws that error, instead of crashing the whole program, it's gonna catch the error here and just log it out to the console and then let the rest of the code keep running. So now you see, you made a mistake and then here's my error, but the rest of the code ran and everything else logged out. So that's the idea of throwing an error and try catch blocks. Again, surface exposure. We're not going to get into error handling patterns and all that in this module, but just know that that's one way you could do that. And that would be pretty common in a constructor function to just say like, hey, validate what you passed in. And if something's wrong with it, throw an error. And then whatever tried to create that object with the constructor can decide how to handle the error, right? So maybe I do want it to break here. And in which case I could rethrow the error. Everything is broken. That's called rethrowing. So now you see I get my two errors. I get the original error that I caught, and then I threw a new one. Everything is broken, and nothing else happened. Because we have what's called an unhandled exception here. I threw an error, but nothing is catching this one. This catch block caught the error I threw here. So we got to log this out, but then I said, go ahead and rethrow it. I want everything to break at this point. So that's the idea of rethrowing, is you catch and then throw another error. But we're getting into patterns there. We don't need to. That making sense though on constructor functions? And similarly, instead of a constructor function, there's that object.create option we showed you. So we could do something like const location base. Let's do this. I'll do base location equals, and I'm going to just grab the same properties and say this is what a base location looks like. And then I could say const new location, actually my location, because I already have a new location, equals object.create. And we're going to use base location as the prototype. And then I could say, well, I want it to have a different name. So I can do my location.name equals new name. And then let's log out location. Okay, so what we're doing here again is I'm saying, okay, here's an object literal that I'm going to use as a prototype. I'm going to make a new location for myself using object.create and saying use base location as its prototype. I'm going to update the name, but only the name. So everything else should stay the same as the prototype. And then we're going to log it out. Let's see what we get here. Back to this problem where GoStore is not defined because it's, you know, a function. I'm going to do something really silly here and make these all empty arrow functions. So we're going to pass in 3 functions that do nothing, or a no op. So if you don't write any functions, none of your buttons will do anything. The default prototype provides no button functionality now, but that will stop that error from happening. Now we're back to where I was before, where we have the problem of where my earlier errors down here. So I'll go ahead and clear that error by just passing in a 3rd function also for now. And now we're back to everything working. All my logs pop out, stuff is all happening here, okay? See here, when I logged out my object, when I logged out the new my location here, it only has a name, but it has a prototype object that has 3 button functions, button text, name, and text. And so what's going to happen here, I'm logging out my location. If I say, notice we only updated the name. So if I want the text, if I say my location dot text, even though we didn't define text on my location, right? My location right here, if I close up the prototype, is just a name. But the prototype has a text property. And so in JavaScript, if you try to access a property or call a method on an object, and that object does not have that property or method, it will go up the chain to look at its prototype and see if it could get a property or method with that name off the prototype. Right? So that's why I can still call text here. I could still call button functions, although they're all empty. Because this has a prototype that defined essentially default values for all those things. Okay. So that's the make a prototype and then use object.create with base location as the prototype. So now all of these are what we would call inherited properties, but name is an owned property because I set it directly on the new object, which is why when we log that out up here, it just shows me that one property. This is the owned property of my location. And then it inherits button functions and button text and text from the prototype. Notice prototype also has a name, but the name is town square. But if I log out my location.name, I get new name because there's both a name on the local object and a name on the prototype. It's going to use the thing closest to what you're accessing, right? So because my object actually has a name property, it's going to use that one. It's only going to go up the chain to the prototype if name doesn't exist on my local property. So if, for instance, I then did delete my location.name, and now I say my location.name, I get town square because that's the name on the prototype. Since my location doesn't have its own name anymore, it's going to get the one from the prototype. Okay, so that's like a super high level introduction to inheritance. But I think it's useful to know that you can create objects from prototype objects like this, or from constructor functions like this. Because as you've seen now, I'm sure between your shopping cart items and locations, building up repeated objects over and over again by writing object literals will get tedious when you end up with a menu that has 1,000 items on it. Right? We just want to pass in the things that are different and let it inherit all the things that are the same. And so constructor functions or prototypes are really useful ways to do that. So stuff you can play with there. Okay. Cool. The last one, and I'm really going to try to do this in the world's highest level overview, is the idea of a class. Classes are fairly new to JavaScript. They are a common element in other object-oriented languages like Java or C++. The idea of a class is a combination of properties and methods that we can call new on that gives us a new instance of that object. So it's just a recipe for creating an object. So just like prototype is a way we can create an object from a sort of like base prototype, and a constructor function is a function that will build us an object. A class kind of encapsulates all of those things. And so we could also have done a similar approach to our shopping cart item by saying class. Actually, I'm going to do some new file so we're not too confused about it. That did not do what I wanted it to do. Make me a new file here, please. In the right place. Call it class example. Okay, so this is just a JavaScript file, and I could say class shopping cart item. Okay, and in this case, I might just make it item. Keep it simple. Okay, and then in here, we're going to have a constructor function. This is exactly like what we were doing before when I had said function item with a capital I, and I could then call new on that to build me an object. Same exact idea with the constructor function here. So I'm going to say it's going to take a name, it's going to take a price, and it's going to take a quantity. Let me start there. And then wait for it. This dot name equals name. This dot price equals price. This dot quantity equals quantity. So identical to writing a constructor function if I had just done function item and name, price, quantity, and use the exact same body. Okay, same idea there. But I can also start to do other things like say all items have a price that or quantity that starts at 0. And then I only will update the quantity if quantity is passed in here, right? So I could say, if you give me a quantity, then set it. But if not, then it's going to be 0. It's going to default to the default value for the class. And you can do all kinds of other stuff with classes. So again, I could have say hello on here as a method. So this syntax gets a little different. Because I don't have to write since I'm in a class, instead of having to write say hello as a key is a function that does a thing. In a class, you get this shorter syntax, which is you just say it's a function, it's a method that you'd call like that. And then it does a thing, okay? And then I could use this by saying const item equals new item and pass in class item for its name. Price is 9.74, and I'm not going to pass in a quantity. Apparently, I'm going to autocomplete some really random stuff. And then I could do item dot say hello, and that would work. Okay, so it's very similar to a constructor function. It's just that a class is a combination of properties and methods that are like a template for making an object that you can then call new on. Okay, so classes are another way you could do that. So you could create a class for each of your shopping cart item, and then every time you need to add a new item to the shopping cart, you just do new shopping cart item and pass it what it needs. And so classes are useful when, again, you have a real world object. So if we're thinking about a car or a person or a menu item that has the same combination of properties and methods every time we have one, creating a class to like encapsulate all that stuff. So it's just like, great, give me a new car. Here's all you need to know to make a car. Here's all the things I can do with a car. That becomes useful. If you're trying to just do it in a constructor function starts to get large and unwieldy, then that's usually a good sign that this might be time to use a class. Just to, again, to kind of encapsulate this and make it something where in the rest of my code, I can just give me an item. I don't have to worry about how all of this works so much. I built a template once and I can use it over and over again. Okay. So that's classes, and that's kind of the way we can. Those are our most common ways for creating an object, okay? So in review, an object literal, which is just this guy here, const shopping cart object equals curly braces, define your properties and methods. That's our object literal. Constructor functions, we're talking about a function with a capital name for convention, the properties you want passed in when you create a new one, and then whatever the logic is for actually building up that object, where this references the new object that's being created. Okay. So we've done constructor functions that way. Then there is the object create with a prototype approach. So you define a prototype object and then create a new object using that other object as the prototype. And there it's going to inherit any default values or methods from the prototype that you don't define on the new object. And then there's classes, which work in a very similar way to constructor functions and prototypes. They just kind of shove it all into one larger container. And I don't want to overwhelm you with getting into the details of classes. There's a lot more powerful stuff you can do with classes, like hiding properties so that things outside the class can't, like only the class knows about those properties and the other stuff can't look at them and other things like that. That's a whole more nuanced thing for the next module. But those are kind of your core ways to create objects. And if you're using constructor functions or classes, then you'll be instantiating a new object by the new keyword. So give me a new item or a new location or a new whatever. If you're using new, the new keyword in JavaScript, that means you're calling a constructor function, which is either, again, defined as a regular function with a capital case name, or as a constructor function inside a class definition. Either one will work. So the new item here calls constructor, or new, we're going to do it here. New shopping cart item here is calling my shopping cart item constructor function. So constructor functions and classes are very similar. Classes are just a little more powerful and kind of expanded upon and have a constructor method inside of them instead of just being a constructor function. That's how we make objects there. So let's talk about like useful ways we've used these. Hopefully some of this now is going to be some review because again, we did that earlier rounds of exposure. So One of the most useful data types in JavaScript you run into all the time is an array of objects. You've already built this. Your locations array in the Dragon Slayer game was exactly that, right? So we had an array, which is just a container, and that's position dependent, and it was holding a list of objects. So for reference, I've got the whole thing open in another window here. I'm just going to pull it over. This was the end result of the locations array. So here we have a locations array, just a container, and the items in here are all objects, right? So this is the object at index 0 in the locations array. This is the object at index 1 in the locations array. And so you built your buttons to go through to change locations by going to locations index 2 or locations index 4, right? And this is a common pattern that you have like items that are in a collection that are all similar, like our locations all have the same properties, or your shopping cart items all have the same properties. And I want to hold on to a collection of objects that all have the same properties. So if you're thinking about things like shopping carts or locations, etc., an array full of objects is often the data structure that makes sense for that. Because then I can just get the right one from the right position out of the array, and that object will have all the stuff I need inside of it. Right, and we saw that. We'd switch locations, and then our functions could get the name of that location and set the button text and set the button functions and set the text for whatever object we pulled out of the array. Okay. Another way you can think about this, I love this note from Zach. It's think about it like an Excel spreadsheet, right? So let me do another. So, an example here, if we were just going to say, if everybody here used a spreadsheet at some point, Google Sheets, Excel, something, the basics of a spreadsheet, right? It's a collection of rows and columns, right? So if we just wanted to define that as a JavaScript object, let's do it like this. Const rows, actually I'm going to do let because we can add and remove rows from a spreadsheet. No, it's going to be a constant container though, so we can leave it const. Okay, this is an empty spreadsheet. I just made an empty spreadsheet. Okay, my first row is going to have first name, don't worry about the fact that I used what's called snake case for these property names. You could do it in camel case, you can whatever. It just have to be those valid identifiers to not quote them. It's just a habit of mine. Okay, and then I could say, okay, cool, we need another one of those. So I'm picking on Jason because he's in the top corner of my screen. So what's your favorite color, Jason? Oh, you're muted.
Green.
Green. Okay, great. So I'm missing a comma there. So can you all see how this would translate into a spreadsheet? I'd have 3 columns in the spreadsheet, first name, last name, and favorite color, right? And then in the first row, the values would be Eric, Kyle, and blue. And in the second row, they'd be Jason, Newsom, and green. So you can define a spreadsheet as an array of objects as long as all of the objects have the same properties, right? Because it's a grid, so they need to have the columns as properties. That's an array of objects. It's just a collection of rows that all have the same properties. Okay. We've talked about the shopping cart a little bit already, so I'm not going to jump past that too much. Hopefully it's becoming pretty clear that an array of objects might be a really useful way to track your shopping cart. An item that got added to it is an object of that item, right? Cool. You can have an array of objects that have arrays in the object. So a good example of this is like a blog post with comments, right? So like here's a spreadsheet example. Let me save this as arrays of objects. Just so, because I'll push all this stuff up so you'll have it later. So that's a spreadsheet, right? And then a blog post with comments. So we might have something like posts. And each post is going to be something like an author, a title, the awesomeness of comments and objects. I don't know. I got nothing. It's always hard to make stuff up when you're just typing around things, right? And then we might have somewhere between 0 and 1,000 comments on this blog post, right? So we could do comments, and that's going to be an array. It's a container for comments. And a comment could be an object, right? That looks a lot like commenter. I'm going to say this one was Jake, and comment. Jake thinks I rock. I'm just putting words in his mouth. That's fine, right? And then maybe Tonalia leaves a comment. So we have another one in there. And she thinks I should be better because I probably should be. So this is great. Okay, right. And you can see like now I could do something like to add a comment. I'm not going to write a function for it right now, but I could do posts. The first one dot comments dot push and shove a new comment in there. Making sense? So this just added another comment to this first post because I grabbed the post at index 0 in my array, grabbed its comments property, which is an array, so I can call push on it. And then I pushed in another object that looks like my other comments. Now you can see how many places I could have made a mistake here by not putting the right properties in my new comment and other stuff like that. I have to pay attention to making sure I match all that stuff up right now. So this would be a great use case that there probably wants to be a constructor function or a prototype or a class for a post and another one for a comment. So that in here I could just do new comment, right? You can see how this would get much easier if I had, for instance, done just a constructor function that takes a commenter and a comment and then sets this dot commenter that, and then here, instead of pushing in this object literal, I could do new comment from new guy who wrote some words. You can see how that's a lot more readable, right? Especially if this object has more than 2 properties in it. Like passing in that huge object literal would be really annoying, but being like, oh, hey, in the first post, in its comments array, push in a new comment. This becomes really usable. And I know when I create a comment, I have to pass it a couple of things, a commenter and a comment. Great, magic sauce. Same end result, okay? Like, except that now I will actually know when I log this out that the type of this thing is a comment because it was constructed by that constructor function. All right. So that is an array of objects with an array of objects inside the object, right? So you can nest this forever. You know, I could know who the commenter's friends were. Let's call it friends. And have that be an array. And then this is going to be people objects. So we're going to have a name and an address or whatever their email for their friends or whatever it is. Now you can see I've got a problem here that, well, sorry, Jake, you don't have any friends. So I have to initialize this to an empty array. No offense, but I wanted an example. So because these need to have the same properties, otherwise there's a chance I could go access friend, assume I can look for, does this commenter have any friends? And if friends wasn't defined, I'm going to get undefined back instead of 0 here and 1 here, right? So this would be another place where now maybe like there's a person object that we want a constructor for that we could use to create these objects, etc. So that's the whole reason we're trying to look at these ways to create objects, is that, you know, when you have repetitive object construction, you can do some nice things to kind of simplify that. Okay. Neat. All right. Similar to this idea of an array of objects is the data structure we'd call a record collection. And I don't mean your vinyl records, but that would work. Now I'm actually going to have to make it as a collection of vinyl records in the example. Let me go ahead and make another new file in here just for funsies. Yeah, maybe I'll make a new file in there. Can't type because people are watching. Okay, so this is going to be very similar to the idea of what we did in the arrays of objects here, where we had an array full of objects, except instead of an array, we're going to use an object full of objects. And the reason for that is we want to be able to, instead of getting these back right now, to get the first post, I only care that it's the first post. So I'm grabbing it by index 0 because we're using an array, which is based on position, right? And when we started back earlier today, we were talking about arrays, we get stuff by their order, by their position. So that is the way that makes sense to organize the data you're getting, is like what order it's in and getting it by order. Array of objects, great way to go. But sometimes you want to get it by the name, right? So what if I want to go in here and grab, you know, the row where with Jason's name in it? I either have to know that that's the row at index 1 just by looking at it, which seems not always terribly useful, or I'm going to have to go find the object that matches a certain criteria. And that's where array find would be useful. And we'll look at that one in a second. But alternately, we could actually, instead of using an array here, use a key. And let's assume that name had to be unique in this spreadsheet. So your name could only be entered once. That means I can use your name as the key. So we could, in our record collection version, be like, let's say const users. And instead of an array here, we're going to make an object. And we're going to key users by their username, which I'll assume is first name, last name. So then I can do, you know, Jason Newsom. Can't use a dash in an identifier. And then this is an object. First name, Jason. Last name, Newsom. Right. And then we have another one in here. That's me. And I'm going to put Allie in here too, because I'm just grabbing random names out of my brain at the moment. And then, I don't know, it'd be useful, like, let's do this one. Let's add a Boolean here. Jason, are you sick? I know Allie is, so she was up. So you're not sick. I'm not sick. Allie is under the weather, so is sick. So Allie is true. That face. Okay. But now, instead of having to know if I want to get Allie's person record, I don't go users 2, because that doesn't mean anything. It's not an array. But I could do const Allie equals users. I could do users dot that, since I used identifier keys that work, or if I had wanted to key these by strings and use spaces, I could have put Allie in there like this. And then I'd have to use bracket notation, but still works. And then, again, one more, I could do something like let username and maybe that came from, I don't know, a login prompt. And then here I could say, go get me current user is the user who is keyed under whatever the username value is, right? So this is going to hand me back this object. So then I could do things like if current user dot is sick, Uh, Great.
Oh, thank you.
Yeah, you got it. Just see what's happening here? Does this sort of make sense? As to a record collection, we're now, instead of indexing by position, I'm giving us a unique key for everything I'd want to get out of this collection. So for instance, this would be another way you could handle your shopping cart. So when we look at your shopping cart, if I said that my shopping cart was a record collection, then your items might be like latte, price $2.99, quantity 3, right? And then maybe we have what else do people drink? I'm an Americano drinker, so that's what's going in our coffee shop thing. And it's gonna be 99 cents because that's what I want to drink, so I'm making it cheaper, and we're gonna have 99 of them, like we're playing beers on the wall. Great, okay. Right. So now if I want to update, if I want to add a latte, right, I could do function add latte. Not that this is the right way to do it. I'd probably genericize this to add item. Let's actually just do that. Let's do add item to cart. And it's going to take an item name as its one parameter for now. And then what I would do is shopping cart at item name dot quantity plus equals 1. Or let me do that slightly more explicitly, equals shopping cart item name dot quantity plus 1. There's lots of edge cases you can get into here, because what if this item doesn't exist in the cart? What if its quantity property isn't defined yet? Like, so, you know, you start to get into these things like you've done probably a little bit of on the form validation exercise. If you started that, of just like, what happens if they type in the wrong thing? What happens if we don't set a value on something? And those just become edge cases you have to think through and use if and else and try and catch and those sorts of things to decide what the business logic is of how you handle those things, right?
Question.
Yep.
In this example you just did, are you making it so basically your shopping cart object has every item in it, starting with 0, and then when like the customer wants to add something, it just adds it to 1 kind of thing?
Well, that's kind of, you're kind of getting at exactly what I'm saying. So I would not preload my shopping cart with all of these, but the point you bring up is very valid. So if I try to add an item name, if I do add item to cart and we pass it something like, oh, chai. I want a chai latte. Well, this is going to break all kinds of crazy ways, because I'm doing this chained access. So I'm trying to access a property called dot quantity, or I'm trying to access a property called quantity with dot notation on the object in my shopping cart that is keyed by chai latte. Well, there's no object there. So what is shopping cart chai latte going to resolve to?
Undefined.
Undefined. Does undefined have a property of quantity?
No.
So this is going to be an invalid property access error. Okay. So what we would really need to do in here is say, okay, if, and we need to check and see if that item already exists in the shopping cart. And if we do, we'll increase its quantity. And if not, we need to add the whole item to the cart, right? So there's a few ways we could do this. Remember that I used that object.keys method before, which returns an array. So that's going to bring back all the keys in my shopping cart. Includes as an array method. We'll put that inside my if check. So let's talk through what I just did here. I said, let's look at all the keys in my shopping cart And if that list of keys includes the thing we just put in, then I know it's in there. So I should be good to go ahead and grab its quantity and update its count. Right? But if it's not in there, we need to do something else. So else, we're going to shopping cart at item name is going to equal. And now I have a problem because what do I set the price to? Don't know. But I do know quantity is going to be 1. So we just discovered a little problem in my logic here, right? If I'm going to have to add the item all together, I'm going to need to know its price also. So we can add a price method here and set that to price. Okay. Now, here, what's the problem is what happens if I only pass in an item name thinking it exists and it doesn't exist, but I thought it existed, so I didn't pass in a price when I called it. Now we need to do this. So if we're in this block here, this is the case where we could do if price wasn't defined, if it's not passed in. So if price is falsy, or if price equals undefined. Right. So we talked briefly about truthy and falsy, but the basic idea is if you try to treat something like a Boolean that isn't actually a Boolean, JavaScript has rules for how it will decide if that thing is true or false. Most things are true. The number 0 is false. An empty string is false. Null is false. Undefined is false. Falsy, I should say falsy for all of these because they're not actually false. False is a real value, right? So whenever I just try to treat something in an if statement like it's a Boolean, you need to know if that thing is truthy or falsy. That's what all those words mean is if I try to treat it like a Boolean, will it evaluate to true or evaluate to false? So if price is undefined, that would be falsy. So I can simplify this by just saying if not price. So if we don't have a price, then let's go ahead and throw a new error. Item not in cart and price not provided. Okay. So now if I try to do this and I pass in chai latte no price, this is going to throw an error and be like, oh, you tried to add something that isn't already in the cart, so we don't know what its price is. So you have to give us a price. Just going to blow up on me. But if I pass price, $3.99, then that's going to get set. My shopping cart at the key chai latte will have a new object added as the value with the price as $3.99 and the quantity is 1. Okay. See how this sort of works now? I'm saying, okay, cool. If it's already in there, then just up its quantity. If not, make sure we have a price. And then as long as we have a price, go ahead and add a new item at that key to our shopping cart record collection, to our object. Let's see if I can just run this in Node real quick for funsies. Are we in here? We are in module 2. 6. If I just run, I wasn't actually planning to run this, so I don't know how broken this might be. We're about to find out. Oh, it worked. Neat. First try. I never have code run on the first try. That's not true. But... All right. So our current user, because we set it here, our username is Ali Alonso. So we got her out of the users and recognized that, well, she was sick. So we got our get better soon here. If we wanted to be nicer about it, what else could we do? We could do let's make this actually, let's use a template literal because I think it's easier. Let's do current user dot first name. And then if I run that again, See, now we give her a much nicer well-wish username, right? You can see how I did this, right? So we got our current user by indexing into our users record collection at the username. So that gave us back this object. And then I accessed the first property on it. And added that to my string. And then down here, you can see what's happening, right? Our shopping cart before has just the latte and the Americano in it. Then we call add item to cart with chai latte and $3.99. And after, we now have this shiny new chai latte in our cart at $3.99 with one of them. If I, let's just duplicate these two lines real quick. So we're going to add add the latte a second time to test the logic. And then you'll see what happens here. So now we got one chai latte, now we got two chai lattes because chai latte was already in the cart, so we just added it. So you'll notice if I omit the price from my second call, I won't get an error because we already have a chai latte in the cart, so we already know what the price of a chai latte is. No problem. However, if I omit the price from the first one, we should get our error because we can't add a new item to the cart without a price. Yep, big old ugly error. Look at that. Item not in cart and price not provided at line 23. And what's on line 23? Right here, we threw this error, which means we didn't have a price. So we're making sense how you interact with a record collection. So for your shopping cart, there's a couple of ways you could approach this. You can either do an array of objects, and then when you want to go modify a specific object in there, you can find it. Okay, and we'll look at that method here in a second. Or you can do a record collection where you use the name of the item or some other unique ID that ties to your HTML element that has the button on it. So we know which one it is, right? And use that as the key in an object, and then have that relate to the item definition. It's not that one is better or worse, or you should always use one or always lean towards the other. It really just depends on, is it going to make more sense to you to have to search the array for the thing you need to act on it, and or have benefit to being able to access in stable order, like a sort order, then you want an array. But if what you want is, I want to go in and look and grab a specific item instantly, then what you want is an object. Okay. You can kind of think of an object as a map where I put something into it and I get something else back out of it. They're often used for translations for this purpose, right? You could put the key as the English phrase and the value as the Spanish string. And then you could just say, cool, if they click the Spanish button, change the text of this element to whatever the phrase is at this English key. Translation map. A few things left today. Okay. So we've talked about your shopping cart stuff quite a bit. I want to show you the find approach. If you didn't see it when Dancy and I are working back and forth on it. So in our, see, I have an array of objects example here, right? So we have these rows, and let's say in this row, I want to go grab the row that has my name in it. And I don't happen to know that it's the first one. And it's possible that this array could get sorted, so the order could change. But I want to know I always get the row that has my name in it, assuming that there's only one row, that first name and last name have to be unique. So let's go get it. So const Eric is rows.find. Okay, and that's an array method. Find has this huge long signature, but all it really means, if you actually start to pick it apart, is it takes a function that should return true or false. It's one of those truth test functions we kind of touched on in arrays earlier. So it will return the first entry in the array for which your little function returns true. So the argument to find is a function that takes a name. And so typically I'll do this with an arrow function. Okay, so we're going to put a function in here. And I just need to give it a name for the parameter, which is what I'll then be able to access inside the body of the function each item in the array as. So I'm just going to call it item. That's fine. And what I want to know is give me the first one where item dot, sorry, I don't need curly braces here. I'll cover that difference because I'll do an implicit return. So I need to write a Boolean here, something that evaluates the true or false. So I want to know if item dot first name is strictly equal to Eric. Okay. Let's run arrays of objects. Hey, look, found me, magic sauce. I'm right there. Look at that. Right now, this would get really weird if I had to do case comparisons, right? So commonly, if you're not sure on casing, one of the common conventions is to convert everything to lowercase before you compare them so that it doesn't matter how I type Eric, as long as it's the right letters. So we could do a little string manipulation there and say item dot first name we know is a string dot to lowercase. And is that equal to my name in lowercase? And then no matter how it's typed in here, I'm going to get the same object back, right? So this is still going to work. But I could also have done something really weird here like this. And it's still going to work. Because I converted this to lowercase before I compared it to my name in lowercase. That's just a common practice. You can convert all to uppercase too if you want, but lowercase seems to be the generally idiomatic way. But if I don't do that, and I have this type like this, you can see that the problem is going to be, even if I thought that my name was supposed to be typed like that, this is now, oops, this is now going to return undefined because it can't find anything where first name is exactly that. So that's, again, a business logic question. Like, do you want it to be fuzzy matching? Like if they type it in with any casing, or is it case sensitive? If you want a case insensitive find, convert everything to lowercase before you compare. And if you want it to be case sensitive, then don't. That's all that matters, right? So again, for your shopping cart here, you could do, like in Dancy's example, he had an array of objects for all of his menu items. So he was following this pattern that we're doing here, right? And then when your button on click handler knows that maybe you're using the button ID or a data set attribute on the button, something that says this button, when you click this, should add a latte to the cart. Latte is the item that matters, the item name. Then you can do items.find, which item has latte as its name. Give me the first one. Shove one of those into the cart. Now, if you're doing a cart that is an array of objects and you want it to update the quantity, you would need to do the logic we did before and check to see if your cart already has one of those in there. And if it does increase quantity, instead of adding another one of the same item as a whole new object, right? You don't have to do that. You could do a shopping cart where every time somebody buys a second latte, you just shove a whole nother latte object into the array. And then when you want to count how many lattes are in the array, you could do a filter. So let's say we want to know how many Erics are in my spreadsheet. Same idea. It's going to look at every item and it's going to want to know true or false. Should it get kept in the filter? If it returns true, then it will be handed back to me in the result. And if it returns false, it will get filtered out. Right? So I want all items where item dot first name dot to lowercase. I don't have to deal with that weird casing. Except I just did something really weird there by not putting that in lowercase. Okay. And let's log. And I want to know how many of us there are. So I'm going to do dot length. Because filter is going to return me a new array from the old array, filtered out to all the things that return true here. So I should get only items that return Eric. I don't know how many of them there are. So I'm going to ask for length. So if I do that, all I got, oh, I didn't log it out. I don't know. I'll show you one of my favorite console log tricks. So with objects, if you create an object and you only pass in a variable name, what it will do is create an object with that as the key. So what you're going to get is something that looks like this. Where the key is literally the name of the variable, and then the value will be the value of the variable. So where we did, let me look at this other example here. in the record collection. Where I set price equal to price here, because my input parameter was named price and the property is also named price. I could also just do this and it would do the exact same thing. If you don't provide the colon and the value, it will assume that you want the key to be the variable name and the value to be the variable's value. So if you're doing price colon price, you can also just do price and it will shortcut that to the exact same code. So here, where we're doing our arrays of objects, and I want to find this, I use that little shorthand in console logs a lot because this will actually name my variable. You'll see it here in a second in the console log. How many Erics? 1. So it actually logged out an object literal where the thing I wanted was in there. So I could also have done, let's look at that. And now you're going to see when I do that again, Eric is undefined, and how many Erics is a count of 1. And now if I go up here and I add another Eric into the array, maybe with some, got to still be an H, but different casing, and we're only caring about first name, so some other Eric is his last name, and color is gray because it's a weirdo. It's fine, right? Now, when I run this again, I got 2 Erics, and we actually found an Eric whose casing matched that. And notice it found both of them, okay? So we got 2 Erics now in my filter because 2 of them will return true when comparing their first name to my name in lowercase. Make sense? So you could, for instance, count up the number of lattes in your cart by doing shopping cart.filter for where the item's name is latte, and then .length on the result of that filter, and that's how many lattes you have in your cart. Alternatively, you can do the example that we looked at already where you put in here, where you're putting a quantity property directly on the item. And then you have to do the logic to say, is that item already in the cart? If so, bump its quantity. If not, add a new one with quantity 1. Not that one way is better or worse, do what sort of makes sense to you, but just showing that, again, there's not always a right answer in coding, and there are reasons some of these are better or worse than others under specific use cases. But what's more important at this point is that you start to feel comfortable just like creating arrays, creating objects, and then like finding things within those arrays and within those objects and modifying them. If you get to that point by the end of this module, you'll be set up well for the next module, I think. If you're like, yeah, I know how arrays work and I know how objects work and I can create them and modify them and find stuff in them. That's where we're headed with this, okay? So that's kind of the idea there for what we're trying to do with them objects, okay? The quote unquote homework that was associated with this class, we've already talked about the free code camp trajectory, just trying to get through that palindrome checker. It's the next to last one, which is the date object. The date object is dates and times are a hard thing to deal with in programming because if you just think about them for 3 seconds, you've got, are we in daylight savings time or not? Are we in the same time zone or not? What happens at midnight in different time zones? So dates become a whole heady thing to deal with. So the date object is a pretty powerful one. I will say as a consolation prize that date object project is only 24 steps. So it is the shortest of all the ones in the whole thing, but it's a good exercise to just play with a complicated built-in JavaScript object and be able to access methods and properties on it and kind of see how it works. So that's I think a kind of good useful review. And then again, that javascript.info tutorial is like one of my favorites for general review as well. That's what I got. I know we have a speaker coming up, so I can't really hang out too long for after questions, but I got a minute or two before we turn it over to Tabby time. So anybody got anything burning or pressing? That's what I got for today. Got the thumbs up from Jason. I'll take
Yeah, I
it.
feel like I learned a lot of useful things today. Thank you, Eric.
You bet. I will just go ahead and commit this whole hot mess I made today so that you all, and I'll push it up so you all can go to that in the GitHub repo and look at my mess all you want, because I was typing things on the fly as I made them up. But they actually all worked, surprisingly. We got errors when we expected errors and code ran when we expected it to run, so I'll take it. So I think they're useful enough examples for me to just go ahead and push up. Anybody want to see me do that real fast? Since somebody was asking me about Git the other day. I'm in the curriculum main repo. Here's our current status. Those files have all been changed. I'm going to add them all. I'm going to do a git commit. Sorry, that was git add all. I'm using aliases. This is going to be really hard for you. So I did git add all. Oops. Which staged all my files. So now you can see they're all going to get changes to be committed, are all those changed files. I'm going to go ahead and commit them. There's a little message. Update in class examples. And then I'm going to push it up to the origin. Magic. That stuff's all on GitHub now. You all have fun with that. And with that, I'm going to relent my time to the wonderful Miss Dabby, who is excellent at whatever she's about to say, I am sure. Please keep posting help questions and stuff in the channel too. It's really useful to practice talking about that stuff, and your classmates probably have the same questions. At least some of them do. Zach and Tabby, floor is yours.
We didn't know if we wanted to keep this running or.
Yeah, I think there's some people in Tulsa that want to hear you, and there's a few people on the call. You guys, can you guys hear us still on the call? Okay,
Yes.
cool. Perfect. Why don't we give you this cool stand,
Sounds good.
and then I will, so the folks virtually can hear you. Okay, you're not sharing your screen or anything, right? So if you don't mind, just they'll be able to hear you this way.
Perfect. And yeah, no awkward, like you get to look at my back the whole time.
Yes.
Because that's fun when you're a remote person. Like that hoodie is lovely.
Okay. All right, this is Tabby, everybody. Thanks for coming, Tabby.
Of course, super happy to. I wanted to go through this code camp. It wasn't available when I was learning, but my husband actually went through this code camp. So it's a really, really good program, and you're going to learn a ton. So a little bit about me. Today, we're going to talk about kind of like your typical day when you get your first developer job. And I am Tabby. I'm now a mid-level developer at somewhere called Sumer Sports, and we do analytics for sports. My favorite stack is TypeScript, React, and then TypeScript on the back end. Not super picky about databases. I've been a developer for about 2 years. I've been coding for about 3.5 to 4 years. I also did a non-traditional route, so I have a completely irrelevant degree career path previously, changed careers, ended up in tech on accident really, and then did what y'all are doing, started, oh, okay, this is kind of interesting. I'm gonna learn a little bit more, and then just did a deep dive in it and got my first job as a developer a couple of years ago. I was entry-level developer at 2 different companies. My first one, I was an automated tester, and then they moved me into development. And then they had layoffs, unfortunately. So then I had to do a job hunt again and was a junior developer at another company. So I have a couple of places that I've done that at. And so I think you have a speaker, if you haven't had them already, of job hunting, your first job hunt. That's going to be like your most difficult one. But once you like get your foot in the door, you're good. And you're going to have this moment, like you get the notification that you've gotten your first job and you're like, oh my God, I have a job. Yes, celebrate. But then you have that realization of, oh my God, I got a job. I have to do things. People are gonna see it. Ugh. So don't panic as much as possible. I still panic when I started a new place. It's still really exciting though, but you just kind of have to manage your expectations because especially going in as a junior developer, they've probably had you do a little coding exercise for your interview and talked with you. And so they know where you're at. They have expectations appropriate to, okay, this is your first development job. No one's going to expect you to come in and be like, yeah, I rewrote this whole repo and man, you had a discrepancy here. I got that for you. So that's, no one's going to expect that. It's totally fine. Everyone knows that you're in a learning role. And so don't feel super pressured of like, I have to go in and knock out all these tasks and tickets immediately or I'm going to get fired. Not a thing. Not a thing. So when you start the job, you'll usually get assigned a laptop. It'll be Mac or PC, depending on the company. I went from PC for a while and then I went to Mac and I was like, oh my God, I don't even know how to copy and paste on this thing. And then now I'm super all in with Mac. I work at a Microsoft kind of featured company and I still use a Mac. So either way is fine. And you can also like ask them ahead of time. That's something that's okay to ask them of like, hey, what do your other engineers use, Mac or PC? And that way you can look it up and not be like me and literally be like, I promise I know how to code. How do I copy and paste? This isn't working. And so you'll be assigned a mentor. It'll be probably another mid-level or a senior level dev, and that's going to be your best friend. And if they're not your best friend, you're going to make them your best friend. So their job is really going to take you through how to get set up, how to get started, they're going to be your main contact point if you have any questions, because you are going to have a billion. Because I don't care how well you know your language, your coding language and framework, every company is going to do something at least a little bit different where you're going to look at that code base and be like, I thought I knew TypeScript, but what's that? What was that doing? So that's going to happen anywhere. And so the first thing they'll do, you'll get your laptop. They will set up your local so you can at least get into the environment and poke around and see how their software works, whatever they're doing. And I promise you, even as a not entry-level developer, setting up your local is going to be insanely confusing and you can't do it by yourself. I think I've onboarded at 4 different tech companies and it's been a pretty confusing process and it's expected to be confusing because they're always changing how those environments run. And so that's okay. Because I know like when we do like our own projects, we're like, oh, NPM run dev, done. They'll have all these complicated things and that's fine. Your mentor will walk you through that step by step. That's their established process for onboarding a developer. That is totally fine. It'll be weird. And then you'll forget all of it because you won't do it again until you get a new laptop or the company decides to change what they're doing. So that'll be something else that you do. And that'll be a good time to kind of, I'd say bond with, you're going to get used to your mentor and how they explain things, how they like to teach. So setting up your local is really, really good for that. They might have you introduce yourself at like an all hands meeting. And I know I'm super introverted, even though I'm talking right now, that when they'll have you do like, introduce yourself and you're like, I am here. Not a big deal, but that's something you might prepare a little bit for. Like you'll probably just have to say like, hi, I'm here. This is what I like. Then you'll get, after you're set up, you'll get your first assignment and it's like, oh God, I have to be productive now. I have an assignment. I have to finish this ticket. And it's usually something pretty simple. It'll be either add this, little button that does something or add this tiny feature, or it might be a little tiny project of this is a wish list that our other developers don't really have time to get to. And that's okay if you're like me, I was very deer in headlights where I was like, I don't know how to do that. But that first ticket especially, it's going to be time for you and your mentor. You'll probably set up like a meeting time to go through the steps, things you need to do. And what I like to do if I start to feel overwhelmed is I'll go through with like pen and paper, not on my computer, and write down, okay, these are the little steps that I know need to be done. And so I'll write those out and it'll feel a little less overwhelming because it's not like build this whole like web page. It'll just be like, okay, step 1, add a container here. Step 2, add words to the container. So that might help and your mentor might go over that with you as well. And sometimes for your first couple of tickets, they might break that down for you also. So you're like, okay, I have a starting point. And then you'll kind of like doing this over and over again, in your head, you'll kind of start to do that automatically. You'll gain that skill of, okay, I know how to break this down. And so you'll have your first couple of tickets and you'll be paired with either your mentor or it might be a more senior developer on that project. Your difficulty, it'll gradually increase. They'll start you off with something super easy to kind of get used to their workflow and how they do things and their code base. And then they'll gradually ramp you up where it's a little bit harder. And one thing I want you to do is like when you do get into your job, when you have a bad day and you're just like, man, I feel dumb today. I don't know how to do this. I want you to go back and think about what you did on your first ticket. Because we tend to forget with coding, like even now, you can probably do things that maybe you weren't able to do a few weeks ago or a couple months ago. Still do that in your job because it's really easy in the entry-level developer role to be like, I don't know anything. This is getting harder. But if you look back and you're like, oh, well, I can do this stuff now and I couldn't do this when I started. So that's one thing that kind of like helps as well. And there's some non-coding things that you'll kind of learn too, like you'll learn Slack or whatever your workplace uses, which slight plug for Techlahoma Slack. If you're not already on it, you should be on it. And then you'll already know Slack if you work somewhere that uses that. You'll learn about the release schedule, how often they push stuff to live. If there's a busy season, like for my job, we do football analytics. And so during the NFL draft from like January to April, the last week of April is our insanity season. So some jobs, like if it's tax software, will have about the same schedule. So you'll kind of learn the cadence of like, okay, this is the slow time. So this is when we're going to work on like wish list things that weren't a priority, or this is crunch time. I already know this is when we're going to be insanely busy, and it's different everywhere. Not everywhere has those like high ups and downs. So you'll kind of learn as you go how they do that. You'll also learn code reviews, which are really, really important, and you'll learn so much from code reviews. And different places will do it differently. So you'll finish your code, you'll create a pull request, and usually your mentor will look at it. Maybe the other developers will look at it and they'll give you comments. And I remember I always get the comments, it's in my head forever from my mentor of, it's not wrong, but because it would work, but I would probably find the most complicated, not efficient way to do it. So I was thankful for the it's not wrong, but part. So though it's not that your code's wrong. It's not that people are like, God, you're dumb. Why did you do this way? No one's gonna do that. And if they do, don't work there. No one's going to do that. It's going to be little comments that'll just be like, oh, hey, you forgot this little thing, because we're always going to forget those little tiny checklisty things. Or this works, but here's a better way to do it, and here's why. Because this works now, but when we add to it, it's going to be a nightmare. And that's one thing I feel that I really learned from, because I was like, it works. Yay, I'm done. Okay, here you go. I didn't really know anything about performance, or if I was going to make somebody's life suck later that had to touch my code, and they would curse me later and not like me very much. So that's something you'll learn a lot from code reviews, and those comments are going to be so helpful. And something I learned a lot from is I'll look at other people's code reviews. Like, when you start, you're like, I don't know enough, I can't approve, or not approve this code PR, but still look at them. You can still look at them and be like, okay, I know what their ticket was. They had to make this thing. Well, now I can see specifically the code that they did to make that happen. And then if you have questions about like, okay, on this code review, I saw you did this, but I don't understand how that works, you can always ask the developer and you can learn further from that. And maybe you'll learn something that helps with what you're working on, or just something you'll do later. And that also helps get used to like how that company handles different situations as well. So definitely, I call it lurking. I lurk a lot in code reviews. Super helpful. You will also learn about ticketing systems. Places will do that differently as well. Is you'll have a ticket per task. You'll have a bunch of tickets per project. They'll use different software. Like there's Jira, there's I don't even know, Shortcut that changed the name of the one my job uses. I couldn't remember it, where it's just like little cards and you drag them on your process of like, I'm working on this, or I'm done with this. So you'll learn the workflow for that, because then you'll have product managers and project managers come in. Are you done? Like, is this done? And what's this ticket status? That's going to be something to learn as well. And so as you're going on, you're going to start And you're going to kind of start with you're going to have your foundational knowledge of coding that you're going to learn here and from your self-study. And then once you get in there, you're gradually, your progress is going to shoot up real fast at a job. But in the beginning, you're going to have a lot of questions, and that's okay. They expect you to have a lot of questions. It's a little worrisome if someone's new and they don't ask a lot of questions, because then you're like, are you okay? Like, are you still alive? Okay. So definitely ask all the questions. One thing I would advise is to Google all of your questions first, if you can. Some things you can't because it's specific to that company. Like if you're have a question about like, okay, where in this repo is this random thing? I mean, you can't Google that because that's specific to that company. But if you're like, I can't remember how to do a nested loop, which I've never done in a job, but just an example, try to Google it first and at least kind of get a little bit of information before you go ask your mentor, because that's going to go really far with them. And also your mentor is probably dealing with 1,400 tickets that they have to be responsible at the first time. So they're kind of having to divide their time a little bit. So it's a lot easier on them to kind of context switch with you when they're like, okay, I don't have to explain this from page one. You've Googled this, you got this far. Okay, here's the like missing blank piece that you couldn't find to make it work. So definitely Google absolutely everything. And another thing you can do is like you have your mentor, you'll probably be on a development team of say 5 to 7 people. And what I like to do is my mentor is definitely kind of like my home person. That's who I ask like project wise, but I will spread my questions out amongst the other developers because they have different interests. Maybe they're good at different aspects of the software. Like I had one guy, if I was doing front end work, he could just look at a page and be like, that box is too far right by 1 pixel. Like it was amazing. So I got to where I would just send him my front end stuff and be like, does this look weird? And he'd be like, yeah, 3 pixels to the left there. So you'll kind of like learn everyone's quirks and like what their interests are. And so if you have a question about that particular thing, you can go to that and be like, oh, this person's really good at this. Okay, I'm going to ask them this. It also takes a little bit of, it kind of spreads out your questions. Your team gets to know you. You'll kind of bond more with your team. And then a lot of times everywhere I've worked, when I've done this, those other developers will come to me and be like, hey, remember when you asked me about like the pixels being off and things like that? Yeah. They'll be like, well, I'm doing this thing and I want you to see it because it's really cool and you probably haven't done this yet. So the more you kind of establish that relationship with other developers, they're going to come to you with knowledge. Like it's things you won't even know you don't know yet. And they'll just be like, oh, here's how to do this thing. And that's a lot of how I learned, was also just people coming to me of like, hey, come watch me do this thing. Thanks. So another thing that I would say is imposter syndrome is real. That's where we're like, I don't belong here. And I think especially coming from a non-traditional background is we're just like, oh, I don't belong here. I don't know how to do this. They're going to know. A really easy thing I like to do if possible is I will take an easy task and I will take a hard task especially during my like early days, because that easy task, when it's like, there's a typo, fix the typo on the front end. You still get to do a PR. You still get to check something off your list and you're like, okay, all right, I did something. I can do this. And then you can go back to your hard task and be like, okay, back to this. And I feel like that's something that really, really helps to always have an easy thing and a difficult thing to work on. And you can tell your mentor or your manager this, and usually they're totally like, yeah, okay, that works. We've got enough tickets to go around. And so I want to like have the rest of the time just for a kind of just ask me anything. I've been in tech. I've not been a developer this long, but I've been in tech for about 8 years now. I've also been the only woman at a couple of my jobs, which was definitely interesting and something that is still an issue in tech, but not always. So if you have any questions, now is the time. Ask me anything. Have y'all had the speaker about job interviews yet? Okay, I think that's next week. Okay. Maybe next week. Yes.
So a lot of the students, they're not really too familiar with like, let's call them lexicon, data talk and things like that.
Mm-hmm.
You mentioned the term stack.
Mm-hmm.
Can you elaborate on what
Yes, I still have problems with, I call them vocabulary problems, especially because developers will be talking and I'll be like, can you describe what that does or what that is? And then they describe it and I'm like, oh, okay, cool. When I say stack, usually, especially like when you're first starting your job hunting, people will be like, what stack do you like? And that's like, what coding language do you like? What frameworks do you like? So I always have my list that I do, that I'll go down TypeScript, React for the front end, back end, TypeScript, and then maybe Postgres for the database. So that's just kind of the languages and tools that you like to work with. And that's something you can ask early on with a company, because I feel like a lot of job advertisements will have like a list of 15 different languages, but you can't actually tell what that company uses. That's something you can always ask of, like, what stack do your engineers use? That way you can get an exact thing.
Can you hear me?
Yes.
How do you keep your skills up to date outside of work?
That is a great question. And it's, so I do this personally. Everyone else is different. Everyone kind of gets their own kind of like, how do you study kind of workflow going on. So when I first start a job, your brain will be mush getting caught up with that particular job and their code base and that kind of thing. Once I get a little established, then I will still do little study side projects on my own. Like maybe I'll do like, I think right now I'm doing like 3 days a week for about an hour to 2 hours of just making something in a tool that I've heard of or comes out, because tech changes. I feel like tech is like, years in tech is like dog years, because stuff changes so fast and there's no way you can keep up with everything and learn all the new tools. And then also talk to your other developers, because I almost guarantee you that the rest of your team is going to be doing the same thing, and they're going to be like, oh, I read this new article on this library that just came out. And so there's a lot of kind of like cross-pollination that way as well, of things that you can kind of share your knowledge with that too. But it's definitely like a never-ending field for like studying and keeping your skills up.
I'll be on that note. So with, just pursuing continuing education, everything with your job, does work give you like time during your work week to do that, so you're not having to use your own personal time?
That's good. It will be different everywhere. So when you first start in your entry-level job, everywhere I've been has given me time. They'll, like, I had my first one, they bought me a Udemy course on a particular framework that they use that I had never used before. And so they gave me time, and they'll work it out, whatever works with your schedule. I think I did half days on Fridays, and then the rest of my Friday would just be going through that Udemy course of what you need particular for that job. Now, if it is outside of the frameworks and coding that your job uses, you'll probably have to more do that on your own time. But usually if it's something relevant or something you can make sound relevant, your job, if it's not crazy busy season or a deadline about to come out, a lot of times if I'm just like, hey, at 4 p.m., can I like do this project that is relevant, because I want to get better at, GraphQL that my job is using. And I've never had any pushback on that.
Awesome, thank you.
I think there's some questions in the chat.
Oh, okay. Let me check. Work. Okay, if I was to begin learning code, is there anything I would have done differently? I feel like when you first start learning to code, it feels like absolute chaos, because there's so many things to learn. And a lot of times there's no set, like, okay, you start at A, then you go to B, then you go to C, which is what boot camps are really, really great at, is that structure of like what order you need to learn things in. I would say that I wish I knew that I needed to ask someone that already knew how to code for a little bit more structure, because that I took a lot longer to really start coding because I was just like, ooh, shiny everywhere. So I was getting little bits of things here and there instead of just really focusing like, okay, I need to learn HTML first, then I need to go to CSS, or, instead of just jumping to, I'm going to do this framework that's going to make absolutely no sense because I haven't done step 1 and 2 yet. But it's kind of hard, like you don't know what you don't know until then. So I would definitely say y'all are already on the right path for that. But on the other hand, I feel like you're always learning, like any of that stuff that you're doing, you're still learning something. You might come back to it later and not fully get it now, but that's just kind of part of your journey, and everyone's is going to look a little bit different. So I wouldn't say there was anything that would absolutely be like, what was I doing? Do I have a portfolio of projects, and did that help me land my job? That is a good question because I hear about that all the time. So on my GitHub, which looks a little abandoned right now, especially for my first position, I did have quite a few projects on there, and they weren't big projects at all. Like I would have pinned, because in GitHub on your profile, you can pin repositories. I think they let you do 6 now. And I would have an example of, okay, here's an example of I can do front end development. Here's an example of I can do back end development. Here's an example I can do both. And they weren't huge at all. I wasn't reinventing the wheel. I think one of mine that is still on there, it is a chat between cats. So it can be fun. You don't have to be like, oh, I got to think of something that no one's ever done before that's super groundbreaking. No, just show that you can make something, show that you can finish something, because that's really what they're going to be looking for. And they're going to be seeing that progress. And the little green boxes, I think it's because I'm a video gamer and I really like to have those like completionist, like check boxes. I like to show in there also that, even if I'm not having a full project finished every day or every week, that I'm still making progress. I'm still working on things, and jobs are going to look at that, especially for your first job. Okay, this person's like really into learning and getting everything that they've learned into code. And I've done that before with jobs that didn't look at it and didn't learn. I said at the end of the interview, I was like, hey, we have a little bit of time left. I'd already done my little like coding question that they had asked. Hey, would you mind, since we have time, would you like to take a look at my GitHub, and I can show you projects that I have done that matches what your company does? Because it was lucky it happened to be the same framework and language, which that doesn't matter. It just was lucky. And so I watched through a project with the interviewer of, okay, this is how I did this. This is what this project does. And I really liked learning about, like Socket.io, which is how the cats could talk to each other in that project that I did. And so I always say, like, definitely have something on your GitHub. Don't let it be blank. Doesn't have to be perfect. How did I practice for my technical interview? Did I use LeetCode? Okay, so I'm going to give you my cheat code because I'm terrible at LeetCode stuff. There is a course on Udemy by Stephen Grider, Grider, and it is interview questions. I don't know the exact name of the course, but if you just look up his name on Udemy and interview questions, he not only just takes you through LeetCode, because LeetCode doesn't really explain how it works or why it works, which your interviewer will ask you, because you can go through and memorize LeetCode and be like, here it is. But then when they ask you questions, you're going to be like, I don't know, that's just what I memorized. But that course is so good. And I retake it even now, every time I'm changing jobs or doing interview questions, because he explains it so well. And it's a lot of those LeetCode questions. I think from that course, I have been asked, I think 3 or 4 of the questions that he goes through, or he'll go through concepts that will help you with the others. So I started with that course. I didn't finish it. When you get to binary tree and below that really complicated, not entry level part, like don't just ignore that part for now. If you can talk about it, great. And then I did LeetCode to actually put that into practice, what I learned from that course. Yes, from the chat, that's who it is. But his courses are great in general, but what's my favorite game? Anything that's Super Mario. I'm actually leaving to get the Princess Peach game right after this. Yeah, definitely that. Also, I will definitely say like you're studying really hard, and I know like all of your time, like you have stuff you have to do during the day, weekdays, kids, family, all of that stuff, and then you're cramming all this coding stuff in your head. You're going to be doing interviewing, studying. When you kind of get to a place where you can not be insane like that, just do a little bit of studying, please maintain your hobbies. Like have one day a week if you can where you're not doing interview study, because I feel like my coding brain just stops working after so much coding. Because I started noticing when I was studying for interviews that I would feel like, am I getting dumber? Like I could do this yesterday, but I can't do this today. That's a sign you need a break. Go play a mindless video game that's not even hard. Like, I don't know, go get a coloring book, because I also love coloring books, and you don't have to think about it. So it's like whatever works for you. Like just please take breaks. It will help you. It will make your coding better for sure. But thank you. And I'm Tabby. I don't know what my last name is on Slack. I'm pretty sure it's just Tabby. I have 4 names, so I try to shorten it, and then I forget which one because they're all legally my names. But I'm Tabby on Techlahoma, and if you have any questions, like feel free, send me a message, reach out, and I'm super excited for y'all because this is going to be a really, really good boot camp. And thank you for letting me talk to y'all today.
Thanks, Tabby.
Thanks, Tabby. Great talk.
Thank you.
Yeah, Kimberly actually found me. So I started walking around the building and I tried one door. And I'm like, no. Building.
It's got under. You just have to Yeah. Well, so actually, we don't like extra magic.
See ya.
See ya.
See ya.